guys, welcome back to the channel, and let's quickly configure VPN in our network here. In this our network, we are going to configure VPN from our headquarters to our branch. So for example, let's say you are a remote user. Maybe you've gone on a business trip and you want to access your internal network back to your company. You implement what is called VPN to ensure that you securely log into your internal network. So this is a site-to-site IPSec VPN which is branded on router redundancy. So we are going to have router 1, router 2 here, and router 3. They are going to establish an IPSec tunnel with branch router, that is router 4 here. So let's see the plan. So IPSec site-to-site form. So we're going to configure two phases. So phase 1, we are going to use IKE encryption algorithm of 3 days and IKE hash algorithm of SHA-1. The lifetime we're going to set to 86400. If Hellman group is going to be 2, then a pre-shared key we're going to set to VPN at HQ to branch. Phase 2, we're going to configure IPSec security protocol ESP, then IPSec encryption algorithm 3 days hash algorithm is going to be MD5. So as you all know that VPN is used to connect physically isolated network, like let's say for instance this case where the headquarters is isolated from the branch. So we are going to configure it into stages. So stage 1 to stage 5. In stage 1, we are going to configure internet security association key management protocol policy. Then the next is going to be IPSec transform set. Third, we are going to configure SCL to match the routes. Then the VPN tunnel, you're going to create the IKE peer, and then the crypto map. The crypto map is what is going to bind the VPN group and also the SCL and the transform into the VPN and apply it on the interface. So let's jump into our configuration. So undo the terminal. Create IKE proposal. IKE proposal are going to give it 1. Then in the IKE proposal, we create authentication. Authentication algorithm is set SHA-1. Then encryption algorithm. Encryption algorithm is used 3 days. After that, we are going to configure the Hellman group. So we say group 2. After configuring the Hellman, you're going to configure the lifetime. In group 2, then we configure the lifetime, that is SA duration. Duration, we're going to give it 86400. Then after configuring that, we do the same to this other router 3 here, that is going to act as the redundancy router. So IKE proposal. IKE proposal 1. Then authentication algorithm, you're going to give it SHA-1. Encryption algorithm is set to 3 days. So after that, I configure the duration. So DH Hellman group 2, then configure the duration SA duration, so 86,400 seconds, then quit. Do the same to the branch router. So this is just to create the connection, the connection from the HQ to the VPN connection from the HQ to the branch. So on the branch, you also configure the IKE proposal. So internet key exchange. So IKE proposal 1. Then authentication algorithm. This is SHA-1. Encryption algorithm, you're going to give it 3 days. Then the Hellman, you give it group 2. That's the purpose suggested. Then set the duration to 86,400. After that, the next thing you're going to configure is going to be IPSec proposal. We come to this router here, quit, and create the IPSec proposal. The name we're going to give it PS01. PS01 3 days SHA. 3 days SHA, and make sure that is the same in all the routers that are going to implement the VPN. So then encapsulation mode, you're going to use tunnel. Remember, we have got 2 encapsulation mode, that is the tunnel and the transport mode, but it is the tunnel that is encrypted. So tunnel, then we create the transform. So the transform is going to be ESP. So ESP authentication algorithm, you're going to be SHA-1. ESP encryption algorithm, you're going to use 3 days. After that, I quit, and also do it in the backup router here. So IPSec proposal, use 01 3 days SHA-1 SHA. Then after that, I create the encryption algorithm. So encapsulation mode. Tunnel, then transform ESP, then ESP authentication algorithm to SHA-1, ESP encryption algorithm to 3 days. After doing that, I also do it on the router on the branch side. So quit and create the IPSec proposal. IPSec proposal, you're going to give it will be PS01 3 days SHA. Then encapsulation mode is going to be tunnel. After that, you create the transform. So transform, so you can either create the transform in AH, ESP or ESP, but in our case we're going to create an ESP. After, so ESP authentication algorithm is going to be SHA-1, and ESP encryption algorithm is going to be 3 days. After that, the next thing we are going to do is to configure ACL to match the routes from the network on the headquarter and to the network on the branch side. So we are going to use the advanced ACL, so that's ACL 3000. So quit. So then you use SEL 3000. Rule, you're going to use rule 10. Rule 10, we are going to tell it to permit. We're going to tell it to permit IP source. So the source IP is from this our network. So that is on the headquarter 10.10.10.0. Then in that network we are going to tell it the destination. So the wildcard mask will go 0.0.0.255. Then the destination is going to be so permit source 10.10.10.0 wildcard mask of 0.0.0.255. Destination is going to be 20.20.20.0 wildcard mask of 0.0.0.255. Okay, you also configure the same one on the redundant router. So quit and configure SEL 3000. Give it rule 10 and tell it to permit IP source of 10.10.10.0 wildcard mask of 0.0.0.255. Then the destination is going to be 20.20.20.0 wildcard mask of 0.0.0.255. To come to this router on the branch side, also you configure the SEL, but the network, the destination will now change. So quit SEL 3000. SEL 3000, we want to give it rule 10. Rule 10, permit IP source. Rule 10, tell it to permit IP source 20.20.20.0 wildcard mask of 0.0.0.255. Destination of 10.10.10.0 wildcard mask of 0.0.0.0.255. After configuring the SEL, the next thing we are going to configure is VPN tunnel group. So that is implementing the IKE peer. So enter into our router here, quit and create the IKE peer. IKE peer. The peer is going to be 10.1.1.4 and version 1. In that peer, the thing we are going to do, we are going to set the pre-shared key. So pre-shared key cipher, said VPN HQ to branch BR. After sharing the pre-shared key, we are going to tell it the local IP. So the local IP local address is going to be the address of the virtual router. So 10 of the VRRP 10.1.1.3. Then the remote address is going to be 10.1.1.4. After that, we are going to give it the IK. You're going to bind it to the IKE proposal. You bind the IKE peer to the IKE proposal. So the IKE proposal is set to 1, and you do the same. On this. Create and create the IKE peer. API is 10.1.1.4 version 1. Then pre-shared key cipher set VPN, if that then HQ2 branch. So that the local address will be 10.1.1.3. Sorry. Local address is 10.1.1.3 and remote address is going to be 10.1.1.4. Then we bind it to the IKE proposal. So IKE proposal 1. Wait. I do the same to router on branch here, but it's going to be the other way around. Create the IKE peer. The peer is going to be for the virtual interface. So there's going to be 10.1.1.3, then version 1. Pre-shared key cipher. I want to be VPN HQ2 branch. In the shared key, I'm going to set the local address will be 10.1.1.4. Remote address will be 10.1.1.3, and after that we're going to bind it to the IKE proposal. So IKE proposal 1. Before you actually implement the VPN, first of all you should ensure that the network are reachable, so that while you are on the branch side you are able to reach the network on the headquarters. So ping 10.10.10.10. so it's able to reach, so that the network are able to communicate. So our role here is to implement a secure communication. So after configuring the IKE proposal, the next thing you're going to implement is now to create the crypto map. That is the last stage. You're going to create the crypto map to bind all the configuration that we've set. That is for the ACL, the IPSec transform, and also the IKE policy. So we're going to create the quit, and in that case we're going to IPSec. We're going policy. So policy name you're going to use policy 1. Then let's see, policy 1, the integer range from 1 to 10,000. So policy 1 we're going to give it a value of 10. Then internet security association key management protocol. After that we bind the proposal. So the proposal we said was PS01 3 days. Sure. Then the SCL are going to be security SCL 3000. Then we bind IKE peer of 10.1.1.4. After you bind those three into that policy, you quit and you're going to enter the interface and you apply it on the interface that connects to that VPN. So interface gig 0/0/1. Then tell it IPSec policy. Policy 1. Create, and you also create that the same crypto map on router redundancy router here. So IPSec policy 1. The integer number we give it to 10. Then internet MP sorry, so IPSec, sorry, it was not supposed to be IPSec proposal. IPSec policy 1, policy 1 integer 10, then internet key of that, and after that we bind the proposal of PS01 3dash sha. Then also we bind the security ACL, so security ACL of 3000. For binding the security ACL of 3000, we also bind the IK peer. The peer is going to be 10.1.1.4. After that, you quit and apply it on the interface. So interface gig 0/0/1 IPSec policy 1, and you save and quit. Come to the router on the branch side and you create the IPSec policy and policy name is policy 1, integer of 10. After that we bind the proposal, so we bind the IK proposal. So IPSec proposal we bind was PS01 3dash sha. Then we bind the security ACL of 3000. After that you're going to bind the IK, so IK peer is going to be 10.1.1.3. Quit, and you bind onto that interface. So that interface of gig 0.0.0 that connect to that VPN tunnel. So interface gig 0/0/0 IPSec policy name policy 1. So you apply it on that interface. So you quit, save your configuration. Make sure you save your configurations. So yes, save and save. So display IPSec display IPSec SA. This is security session established. So display IPSec SA. So when you display IPSec SA, this is what you are able to see. So IPSec policy name is policy 1. Sequence number is 10. SCL we set to 3000. SCL rule was 10. The internet session was that, and connection ID was 7. Encapsulation mode is tunnel. The local address is 10.1.1.3. The remote address is 10.1.1.4. Flow source, that is the SCL that we configured, was from network of 10.10.10.0 to flow destination of 20.20.20.0/24. Quality of service was not enabled. So that's how we configure the SCL. That's how we configure the VPN. So let's check also on this branch router. So display IPSec SA, and a display IPSec SA, you are able to see that connection ID was 3, policy 1, sequence number 10, SCL 3000, rule 10, and the mode is tunnel. The local address is 10.1.1.4. The remote address is 10.1.1.3. Now the source network is 20.20.20.0 and the destination network is 10.10.10.10. So let's see if after configuring our secure network we are still able to access, the remote user is still able to access the network and still returning packets, meaning that our remote user can still be able to access the network of the headquarters through a secured channel. So that's how you can establish IPSec tunnel. So IPSec is the most preferred in a large-scale network, because it is the highly secured VPN. So thank you for watching the video, and